Welcome to Bomb School, ladies. Today we'll be teaching you how to construct a grenade. It connects. You will need 8 yellow connectors, 16 green connectors, and 2 snowflake connectors. After you put it all together so it looks like this, you'll have constructed yourself a fine grenade. Good luck. Whatever your intentions may be for a grenade, do not let it explode near your feet. Unless, of course, it's for science. So other than teaching you about grenades today, we'll be teaching you about the conservation of center of mass. The center of mass is the sum of each individual mi times its xi. Now mi is the mass of an individual object times its x-coordinate from the origin, all over the total mass of the object. Because we're learning about the conservation of center of mass, the center of mass before the collision or explosion is going to equal the center of mass after the collision or explosion. For example, we have a bomb here at rest, and the center of mass before is directly in the center. However, after the explosion, the center of mass is right in the center, but we have a large piece directly underneath the center of mass, and 2 smaller pieces further away above the center of mass. Because the piece underneath the center of mass is larger, the smaller pieces need to travel a further distance in order to compensate.
So now we're going to measure the mass of each individual piece. Here's the white one. 3.5. Here's the green one. 2.0. And here's the yellow one. 2.5.
Now we have a demonstration. I'm going to drop this, and since I'm dropping it, its x coordinates and its y coordinates are not going to change at all, only its z coordinate up and down. So when we measure all the pieces around it, the x and y's should all cancel out into the origin, which we have marked as this box. There you go.
Hold on, I'll hold.
He said hold on too late.
Cool. Alright. Ready, set, go. That in a perfect world, without any friction, if an object's dropped from a height h and ends at the bottom of h, which is your floor, you should get the velocity at the bottom to be rad of 2gh. Alright, so getting on to momentum. As you guys learned, the conservation of momentum is the m's times their velocities. So the mass of the velocity of the first ball at the bottom of the ramp will be v1, we'll call it. And the velocity of the second ball, right when it reaches the bottom of the hill, will be nothing because it still won't be moving. Divided by both masses, which is 2m. Which then you get the velocity of the center of mass, which ties into the conservation of momentum, which is v1 divided by 2, which is the velocity of the first ball divided by 2. So the momentum after the collision should also be the same exact thing, which is v1 over 2. So at the end of the collision, you'll see both balls moving at the same exact velocity, which we'll call v2, and the masses stayed exactly the same. Alright, so let's test this. As you saw, at the end, both the balls were moving at the same exact rate, showing that the velocity of the center of mass was conserved.
Center of mass is the total mass of an object. Where is the center of mass? There might be a big piece really close to the center of mass, but the smaller pieces will be further away because we'll cut that out. Chris, I got another one for you to delete. In addition to... What beautiful craftsmanship. God, this could have only been done by Kevin Welsh. Jeez.
Alright, that works perfect.
I know it's perfect. It's beautiful craftsmanship. Compliments of Kevin Welsh. You ever need him in a hurry? Call Kevin Welsh.
You ever need him in a hurry. Which is mv1, which is the velocity of the starting velocity, is equal plus mv of the other object. Here's a little demonstration on what not to do with grenades. First off, don't throw it at your friends.
There you have it. This has been Conservation of Center of Mass.
Cal Tipplers.
Superstatics.
Fine, I'll be nice. Superstatics, the winners. Bye.
What beautiful craftsmanship. God, this could have only been done by Kevin Welsh. Jeez.
Alright, that works perfect.
I know it's perfect. It's beautiful craftsmanship. Compliments of Kevin Welsh. You ever need him in a hurry? Call Kevin Welsh.
You ever need him in a hurry. Which is mv1, which is the velocity of the starting velocity, is equal plus mv of the other object. Fuck that.